So for number 3, we used the graph. They said sine from 0 to pi is equal to 2. And then we use that to answer A, B, and C, right? So we're going to use the same graph. We're going to use the same graph for D and E. The bounds change. A couple things change. The bounds change, and then they add some stuff in there. So D. So it's the same graph. Okay? We're using the same graph, but now the bounds change on D. So let me redraw the graph. Okay. Okay. So for D, now you'll start at 0. You don't start at pi, you start at negative pi. Start at negative pi. So negative pi is on the other side. Negative pi over 2, negative pi. All right. What do we know about negative angles? What do we know about negative angles? Like, where is negative pi on the unit circle? Like, if I were to look up on the unit circle, negative pi, there are no negative pi values or negative angles on the unit circle. So how do we find those? We've talked about this before. How do we find those? How do we find negative values? Yeah, direction, right? Direction. Instead of going counterclockwise in the positive, counterclockwise, opposite of a clock, that is for positives. You go in the opposite direction, right? You go the same opening, the same angle, but in the opposite direction. Okay? So negative pi over 2 is the same as 270 degrees, or 3 pi over 2. Same location. Negative pi is actually the same location as positive pi, just opposite direction. Okay? So if we do that, so with that thinking, over here is going to match right here because it's the same location, right? It's going to match. So whatever happens here is going to happen over here, right? So the graph is going to look like that. Because negative angles, negative pi values, are just the opposite direction. So negative pi over 2 is the same value as 3 pi over 2. Negative pi is the same as pi. Oops, wrong color. Shouldn't do green. Should keep it consistent. And if it gives you the same values as this guy here, it should have the same area. So that guy there is going to have an area of negative 2. Okay, because it gives you the same values. We talked about this. Why is the green positive 2 and the pink negative 2? Because it gives you the same values. They're the same values, just negative. So it's going to create the same area. Okay, so the same thing. So now we just add up the areas. From negative pi to positive pi, we add up this guy, and they cancel each other out. So we get 0. Okay. Letter E. Letter E is one of the things you're going to see quite a bit. And it throws some people for a loop. So again, this is the function here. Right? The function was f here. The function here is now this. So let me ask you a question. What is that plus 2 or that positive 2 that's being added to sine? What is that going to do to the graph? What is that going to do to the graph? Yeah, that +2 is what we call a vertical translation. Vertical translation. It's either going to move it up or down. And since it's +2, it's going to move it up, right? This is what we call a vertical translation or a vertical shift. The difference would be this guy, which would be a horizontal shift. Right? If that +2 was with sign, so in other words, if it was written like this, even better. That would be a horizontal shift, right? If it was written included with the x, but it's not. The 2 is separate from sign. Part of the function, but separate. So you can think of it like we're shifting this guy up 2 units. We're shifting everything up 2 units. So the area is going to get bigger, right? There's going to be more green area there. Another way to think about it is to use one of our rules. One of our rules said if we had 2 functions being equal to each other, we can each give them their own integral. So in other words, we can say 0 to pi of 2 dx plus 0 to pi sine of x dx. That's probably an easier way to do it than to think of it, but it's the same idea. Right? It's the same idea. So this guy we already know. From 0 to pi, that guy is going to be 2. We already know that. That's the green. That's just the green stuff. This guy here is going to look very similar to the very, very first one we did. This guy right here. Right? It's going to create a box. Because the function is just a constant. It's just 3. Here it's just 2. So what is that box going to look like? It's going to look like this. It's going to be from 0, pi over 2, pi, 1, 2. It's going to start here, and it's going to be here. It's above the x-axis, so it's going to be positive. That's what this guy is going to look like. That's what this guy is going to look like. Okay? It's going to create a box. So the base of the box is pi. The height of the box is 2. Multiply them together, you get 2 pi. So we get 2 pi plus 2. It's just 2 pi plus 2. Okay? If you would think about it in terms of a vertical shift, you could do that too. This part right here will be on top of this. So it'll be, all of this will be green. That's essentially what it's doing. It's just moving everything up 2. If it's moving everything up 2, then it's creating this box here. Or you can separate them. Doesn't matter. Doesn't matter what you do. Okay? All right. Okay. So what I'm going to do now is I'm going to let you guys start on the assignment. It's on Delta Math.